After running the image through the forward pass of the neural net, we have obtained our predictions. These are stored here in pred. What I'm going to do is save it here locally, and then we'll import it in our Colab environment. And we can save this with the torch.save. And you can see that we'll save it into a file named pred.pt, which right now does not exist. Now, if I step into this, given that we have concluded this profile, we will close the time. So let me show you. You can see that here, this profile, now we're exiting and we're calculating the delta between when we started and the time right now, as you can see here. And then we'll add that delta to t, which was originally 0. We're not using CUDA, so we'll step over that. We'll calculate the time and now the delta, and then add to the original time, which is 0. Now, when I run this, we create this file, pred.pt. And you can see that it got created right here. So what we're going to do, as usual, is open our Colab environment. So let's go ahead and open it. And we're going to go all the way here to the bottom to Non-Max Suppression. As usual, we're going to mount our Google Drive files. And I have the pred file stored here. So what we're going to do is download it in our files folder. We go here, files. Right now, we don't have that pred file. So let's run this. And you can see that now has been created, as you can see here. Now we're going to import it. And remember that the pred file or variable is this list of this tensor as well as the X inputs to the detect class. So you can see that we call the first index or index 0. These are our predictions. And we also outputted this just in case. But these are our predictions. So now that we're here, we're going to jump into this non-max suppression section. When I run this, we'll enter into this profile as we've done before. We'll calculate that time, start time, and return. And now we're going to run this function, non-max suppression, which takes our predictions, our confidence threshold, which we define it as 0.5, our IOU threshold as 0.45, our classes, which right now is set to none, agnostic NMS set to false as well, and match detection set to 1000. These are parameters that were defined right here. You can see that we have the 0.5 for the confidence threshold, and for the IOU threshold 0.45, 1000, and then we also have agnostic. You see that agnostic is not there, neither classes, because given that we didn't define it there, it took the values from here. Classes none and agnostic NMS set to false. We'll talk about what each of these means in the non-max suppression function, which, by the way, is imported from utils.general.py right here. So the moment I run that at the bottom, we'll jump into general.py. As you can see here, with those arguments. And now we're going to do some asserts. We want to make sure that the confidence is between 0 and 1. So of course that is the case, as well as the IOU threshold. Our prediction, as you can see here, one of our inputs is, well, in this case, is a list. So we're going to step into this, and we're going to get our index 0, our true predictions, really. So we're going to override the prediction variable to only have that index. As you can see here, device, well, it's going to be, in our case, CPU. As you can see here, and given that NPS is false, we'll step over that. And now we're here, where if I go to prediction, and we check the shape, is 1 by 25,200 by 85. So what we're going to do is BS for batch size is going to be 1. And then NC, our number of classes, we're going to get index 2 out of the shape. So basically 85. And to that, we're going to subtract NM. Notice that we did not provide NM as an argument. NM is an argument that is being carried by basically this function, unless we specifically define it. So that is 0 and then -5, because again, as we've seen before from this diagram by Thailand Lee, you can see that the first 5 values correspond to the box coordinates as well as the Objectness score. So we want to get the number of classes here. So what we do is we obtain the total and then we subtract 5 for these first 5 values here. Because this, in our case, is going to be 80. But if you had trained your model with custom dataset, your number of classes could be different. So in our case, NC is going to be 80, as you can see here. And then XC, these are the prediction candidates that are greater than our confidence threshold. So out of all the predictions, we're looking at index 4, 0, 1, 2, 3, 4, the Objectness score. And we want to know, out of all the predictions, which ones have an Objectness score greater than the confidence threshold. So let me show you. So we already know here that prediction is that first index. Here, I'm just using that variable. Here, the variable was converted to prediction, but basically we have the same prediction. If I print that out, or better off, if I look at the shape, we can see that we have a 1 by 25,200 by 85. Now, if we run this function, we already know that BS is 1, NC is 80, and then XC, if I print this out, basically is a Boolean tensor of values false or true, depending on whether out of these 25,200, looking at index 4, so this means that in our case, we have only one image, but if we had more, it would be out of the different images and all of the predictions. This is what the 3 dots mean here. And then look at index 4, this one, and if it's greater than the confidence threshold, then return true, otherwise return false. So basically, this shape just got converted to essentially 1 by 25,200, where each of the values here are either false or true. So let me run this, and you can see that XC has the same shape, but all the values are either false or true.